Okay, as Mike said, my talk today is going to be looking at cavity barriers for curtain wall facades. I'd like to thank Stephen Ledbetter for his talk on the CE marking. I will touch on some of that as well. A very important aspect from us in terms of looking at a curtain wall facade is the movement that's generated within the facade. And I remember having meetings about 14, 15 years ago with people from the BRE, some curtain wall contractors, some specialist installers, and there was dispute around the table as to whether a curtain wall moved or not. I think it's generally accepted now that curtain walls do move. It may vary in how much movement. We as a manufacturer of the cavity fire breaks that go in there can't control the amount of movement. It's down to the designers and the system as to how much movement there is in there. But crucially, that movement is going to be playing all the time on any product, any cavity barrier that sits between the building slab edge and the facade of the building. The sorts of movement that you're going to get: dynamic loads. By dynamic loads, we can look at a variety of different things that can play and cause a dynamic loading, but in the main it's going to be wind loadings. And with wind loadings going onto a building, obviously the higher the building, the more the wind loadings, but they are going to be pushing the glass in, they're going to be pulling it out, they're going to be pushing the mullions, transoms in and pulling them out. And those are going to continuously play on the performance of the cavity barriers in there. Seismic loads. Now, fortunately, in this country, we don't generally have to design as we're showing on there. Sorry, that would be maybe in Tokyo or in San Francisco. They may have to design like that, but nevertheless, I come from Worthing down near Brighton. We had 3.5 on the Richter scale last year, so you never know when seismic activity is going to crop up. And also, very importantly, is the fire aspect. Because generally, the curtain wall facade is an extruded aluminium product which has good stability, but once it reaches its melting point, it drops away quite quickly. It will bend, it will distort, and therefore, again, it will put an awful lot of stresses and strains on the cavity fire breaks that sit in there. So rather than designing our buildings with huge, great structures to stop the movement within it, what we tend to do is we leave this gap between the slab edge and the facade, and it's usually it can accommodate up to about 75 millimeters of movement. And we see a variety of different designs out there, and as a manufacturer, some of these can put quite a heavy emphasis on us to come up with solutions. If you look at that bottom picture there, commonly known as the armadillo in Glasgow, in there we actually had gaps between the slab edge and the facade of up to 1200 millimeters. I can live in a space of 1200 millimeters, frankly. So it's quite a big gap to actually fill and to put something in there that you know is actually going to work when hopefully the worst case scenario doesn't happen and a fire does actually take place. This is an example of what I would call a good specification. And what this is saying, all cavity barriers should be capable of accommodating all structural, settlement, drying, shrinkage, creep, thermal and moisture movements of the building frame and or facade without dislodging. I don't know who wrote this specification. I found this in one particular job that I was looking at. And why I put it up there is, for me, it kind of encapsulates what actually is going to happen to the cavity barrier during the life that it's in there, whether it's 25 years, 30, 40 years, that it's sitting in there. All those things are going to be playing on it. And again, that puts a big onus on us as manufacturers to make sure that we are presenting you with something that is capable of meeting those requirements. So what actually is the requirement? What do the building regulations ask us to do? And And what does Stephen over there ask us to do in terms of the CWCT? The CWCT write in their fire performance of curtain wall and rain screens, the main requirement for curtain walls that are not required to provide fire resistance is the provision of fire stopping between the external wall and compartment floors and walls. And that's largely taken from approved document B. And when you look at approved document B, or you look at the technical handbook in Scotland, or the document E in Northern Ireland, and our friends from Ireland haven't arrived. We've got 5 people come from Ireland. They were all delayed this morning. But I ought to refer to technical guidance document as well over in Ireland, which pretty much paraphrases the approved document B. And you can see the diagram there. And Stephen referred to this in his presentation, that the cavity barriers actually form an extension of the floor slab and not part of the curtain wall facade. And it can get a bit confusing when we refer to cavity barriers. And what it clearly says here, that these aren't actually cavity barriers, these are fire stops. It says at the bottom, fire stopping, same fire resistance as the compartment, and not a cavity barrier. Because generally with cavity barriers, you tend to be looking at maybe 30 minutes performance that you're looking out from them. When you're talking about a fire stop in there, then you're talking about reinstating the fire performance of the compartment. And it's very important. When there's a number of contractors in here that subcontract doing fire stopping packages within a building, so that when the designer has designed his compartments in there, I'm sure they would like to design compartments with no windows, no services or anything, because that's going to give you the best fire performance. But you know, M&E come along and they put their pipes and their services through, and somebody has to come along and reinstate those compartments. And they use a variety of different products. So say you had a 4-inch plastic pipe going up through a floor slab. When the fire hits that 4-inch plastic pipe, it's going to burn away. It's going to leave a gap for the fire to pass through. So you would put an intumescent collar on there. You would fix a collar to it, and that collar will react to the heat, and it will crush the pipe before it allows smoke, heat, fire to pass through. Now, fire is very indiscriminate. And there's one gentleman sat in the back row up there who I always remember me telling me once that he lost the contract on site for doing the slab edge to the contract cleaners on site. Now that's a number of years ago. I don't know what they did, whether they swept the sweepings into it or what they did, but basically it wasn't viewed as a particularly important aspect of the fire stopping on site. Well, as I say, fire's indiscriminate. It will pick the least line of resistance. And if the least line of resistance is between the curtain wall and the slab edge, the main contractor or the client has wasted all their money that they've spent on the other fire protection within the building. So it is incredibly important that that is given its just desserts. The approved documents say the product should be in accordance with a specification or design which has been shown by tests to be capable of meeting that performance or have been assessed against the evidence. And this is something I'd just like to point out to people. It's very, very important. The onus is on the people that design it and install the product to make sure that what they're designing, what they're purchasing, what they're installing is the correct product, and that the testing meets up to the requirement. And the best way to do that is to get a copy of the test report from the customer, from your supplier, of the product that he's going to use. Ask to see the test report or an assessment of it. If, as we often see, you know, you can only test so many scenarios, you're going to get ones that are not tested, then you'll need an assessment done on them. Now, there are guidelines in place, but the Association of Specialist Fire Protection, the Passive Fire Protection Federation, actually have guidance for people on who should be capable of carrying out an assessment or an engineering judgment. For the test houses that are here today, for the BRE and for Warrington Fire, Chiltern, they will follow that guidance quite strictly. Unfortunately, about 80% of all assessments and judgments are actually made by manufacturers and not by test houses. And a manufacturer is trying to sell you product. So be wary whether the person who's actually doing an assessment for you, an engineering judgment, has the knowledge and the experience in order to be able to do that. And they have some supporting evidence to show that when they say that their product will do it, you've got peace of mind, because the onus will fall back on you, not them, whatever they put in writing. What do we test? We test two things, really, in a fire performance test. We test integrity, which is the ability of a product to stop fire passing through. And generally in a test, what you have is you have what's called the cotton wool pad. And if the flame gets through the product and it ignites the cotton wool pad, the test has failed. But if you just want to stop fire passing through, say you had a hole in that wall and you wanted to stop fire passing through it, put a steel plate up. A steel plate will not allow fire to pass through. But what will happen to that steel plate is that it will continue to heat up to the point where you will get spontaneous combustion on the other side. So also part of the fire test is to check the insulation properties of the product. And you can see on there, you can see some thermocouples placed on the product. And basically when these reach a set point, I believe around 180 degrees, then again the test has failed. Now within the furnace, you are talking about temperatures of between 900 and 1200 degrees, something in that region that the furnace is operating at. So you can see that the products have to be very good at insulation to stop that temperature rising above 180 degrees. And I would caution you, if you went down to B&Q now, you would probably be able to buy a fire-rated foam down there that will tell you this product will perform up to 4 hours fire performance on it. What does that mean? It means that in the tests that they conducted, they managed to stop the fire passing through for 4 hours. If you then go and get a copy of the test report, what you will see is that that has been tested in a 15mm gap, 200mm deep. What's one of the main things that fire needs to propagate? It needs oxygen. Once that has burnt through a certain way, no oxygen can get to it, the product won't continue to ignite, therefore it succeeds. You could put chewing gum in there, it would work exactly the same. You extend that hole to 40mm, 50mm, allow air to get to it, that so-called 4-hour product will last probably around 4 to 5 minutes. So that's the importance of checking test results to see how it was tested, whether it's applicable to your particular scenario. What sort of tests are there available? BS 476 Part 20 has been the standard for many years that fire stopping products generally are tested to, and slab edge products have been tested to. What is BS 476 Part 20? It's what we would call a static joint test. It's concrete to concrete or concrete to masonry. You put your cavity barrier in there and you fire test it. There is no movement at all. It is not indicative of how a curtain wall performs, but it has generally been accepted as the standard for people to test their products to. And I think that virtually all the products in the market at one time or other have been tested to BS 476 Part 20. Is that adequate? Is there better testing available? I believe yes, there is. The next test is an EN 1366 Part 4. I stress the 1366 because you'll see the next test, 1364 Part 4, it can get a bit confusing. 1366 Part 4 does allow for some dynamics in the test, but it's still not reflective of a curtain wall scenario. It's still largely a concrete to concrete scenario that you're looking at there. And the final test, which was one that was referred to again by Stephen for the curtain wall scenario, is the 1364 Part 4 test, which is conducted on a curtain wall system, and that is the test that we believe people should be testing to now, and I'll come on to that in greater detail. CE marking. Again, Stephen's given you a pretty good in-depth analysis of CE marking for curtain wall systems. And here's a strange thing in the industry, really, is that curtain wall systems have to be CE marked. Insulation products have to be CE marked. But fire stopping products don't need to be CE marked. Although they're a life safety issue, there is no product standard in place at the moment, therefore they don't require CE marking. You can voluntarily CE mark your product, but it's not mandatory, and I know there's people in this room working towards the goal of having a product standard written for it, and hopefully in the not too distant future, but I mean we're talking years rather than months, you know, there will be a CE mark mandatory for fire stopping products. Stephen again referred to the curtain walling product standard, BSEN. And my eyesight's not good enough to read that, the numbers, and I forget it, so I'm sure you can all read it there. What it says in there, it talks about fire propagation is something that you have to consider, but it says the cavity barriers must perform. And what do we mean when we say a cavity barrier must perform? Well, it must perform to some sort of standard, and there is actually, although there isn't a product standard for fire stopping systems, there is an E-tag in place, the European Technical Approval 026, which is for fire stopping and fire sealing products, linear joint and gap seals. And this makes specific reference to curtain walling. And you can see from this table in Annex D in there, it says, is the linear joint seal's length to width ratio at least 10 to 1? Well, I would think in most curtain wall cases, even with the 1200mm gap, you're still going to get a 10 to 1 ratio there. So the answer being yes. Is the seal load bearing? Curtain wall seals are not, the cavity barrier is not a load bearing seal, so no. And then it says, is the linear joint seal a perimeter joint seal for curtain walling? Yes. And it tells you to refer to EN 1364 Part 4. And so again, the European technical approval is telling you very clearly that products ought to be tested to 1364 Part 4. A couple of case studies that I want to go through. The first one, a lot of people don't recognise that building until I put up the next slide. That is the Tor Windsor building in Madrid. It's a lot more recognisable after the fire that took place there. Quite a devastating fire. The building was built in the 1970s under Spanish regulations, and at that time there wasn't much of a requirement for fire stoppings in there of any sort, and there certainly weren't at the slab edge. So in the 2000s they undertook a refurbishment of the building, and the ironic thing is, if they hadn't refurbished it, it would probably still be standing because they managed to set fire to it during the refurbishment. But there were no slab edge fire stops in place, and as Mike alluded to, I have been around the fire industry a little while now. I'd always learnt that fire goes upwards, not downwards. And yet you can see the fire actually started on the 21st floor of this building that was 30 stories high. And although you can see the top 9 levels there have the worst burnout, you can see the devastation throughout the building. And in fact, the fire spread through every floor level except for the basement levels. So there was something common, there was some deficiency common to the upper levels that didn't apply to the basement levels. Now the services and penetration seals went down through the basement levels, so they weren't the failure. The failure was actually at the slab edge. And some of the fire stops were in place, some were missing, but there were enough missing for burning droplets to actually start fires going down through the building. And I think it was between the hours of 3 o'clock in the morning and 7 o'clock in the morning that it spread from the 21st floor down through all the other floors. So that's quite rapid spread, frankly, through 21 floors and then the 9 floors going upwards. Now, sometimes I get told, I'd just like to welcome the people from Ireland, I think, is it? Who's this? Hi, please take a seat. Good old fog at Dublin Airport this morning, I believe. Yeah, it often gets mentioned to me that curtain walls can burn away very quickly, and that so why do I actually need good fire stops in there? And I'll show you later how you can stop your curtain wall burning away, or largely reduce that happening, and the incidence of fire breakout through the glazing and then back through into the floors above. But irrespective of that, if decent fire stops had been in place in this building, you may have lost the top floors. You certainly wouldn't have lost the rest of the building. And I've looked at other projects which may be referred to later where, you know, compartmentation has worked and it's really reduced the losses and enabled people to carry on working within the buildings. The other one that I'd like to mention is this President's Tower fire in Bangkok in 1997. And the reason this is interesting is because if a fire takes place in this country, the fire brigade will get called along to do an investigation. The investigation usually looks at why the fire started. It rarely looks at why the fire spread and the propagation of the fire. In this case, a company was called in specifically to look at that aspect of it. Building Diagnostics Asia Pacific were called in, and Peter Hartog wrote a very long report on why the fire spread. And he found that it spread rapidly through openings in the floors, including the gap between the curtain wall and the concrete slab. He went on to write that the conventional fibre fire stops, and this is interesting because I know there's some building control department people here in NHBC, I guarantee you would have signed this building off. That there was nothing, these products would have conformed with BS 476 Part 20, they were all in place, the fire stops, and yet it still failed. And what he said was that conventional fibre fire stops were no longer flexible. All such forms of attachment are likely to fail as the curtain wall extrusions deform. He considered that the aluminium support members moved significantly during the early stages of the fire, and that this caused, formed roots for the fire to spread. So having made that point, and I can assure you, we sell fibre fire stops. So I don't want to appear to have just said that all fibre fire stops don't work, and what I'd like to do now is explain the differences between the sorts of fibre fire stops that are available within the market. And it all comes down to the compressibility of the material and the orientation of the fibres within the product. The ones on your left there have a vertical fibre orientation, and the ones on the right have horizontal. Now, when rock fibre is manufactured, the way it's blown, it will have horizontal fibre orientation, which gives it very good stability, but makes it very hard to compress. If you do compress it, and you compress it continually, then you will get a breakdown in the bonding of the fibres, and you won't get recovery out of the product. There's one system that actually says if during a fire the behaviour of the facade panel or the fixing is such that a gap develops between the product and the panel allowing fire to pass through, the company can't accept liability for failure because they've got a product that has that horizontal fibre orientation. This is how the Siderise, this is a patented process that Siderise has to manufacture their panel. Basically, we take a rock fibre slab in, it is cut, it's horizontal fibres, it's cut, it is turned, it is then compressed under factory conditions, and the foil is then applied to it afterwards. And what you end up with is a very compressible material that not only compresses, but recovers as well. And so over a long period of time, that will accommodate the wind loadings and those sorts of dynamic loadings that are imposed on the building. What it won't do is accommodate the movement in a fire. That won't accommodate it. What will is when the foil delaminates from the product in the fire and all that factory-induced compression within there is released and the product expands. And that allows this product to actually work in a fire scenario. There are a number of products in the market that will that work on this principle, but the Siderise one is the only dry product that's capable of having the movement necessary to pass a 1364 Part 4 test. There are wet systems available in the market where you bring your rock fibre to site, you cut it on site, you compress it on site. There are issues with doing that. Once you've sprayed over that particular product, there's no way of telling whether the correct compression has been put in unless you do destructive testing. They're also based on acrylic base generally. They're water. If water gets on them before they've cured, then you will get washout. Once a system like that, the wet systems are installed and they're in place and dried and cured, they will give you a perfectly good seal. But a dry system will do it in probably twice as quickly. Simple to install. You can see the product there. The contractor either buys slabs of it, large slabs that he will cut to size, allowing for compression, or they will say to us, this is the size gap that we have, and we will provide the product to fit that. And they have the spikes going into them, and you can see that the spikes sit on the slab edge, and up to 400 millimeters, they don't need any mechanical fixings to the slab edge. And then the product is simply taped at the joins. Water tightness sometimes is an issue on site. There's a high performance tape that you would use to tape to the concrete, to the back of the facade, that would then give you immediate water tightness on the product. Something else that the CWCT referred to is the fact that the insulant used on the back of a spandrel panel, we have no control over what insulation is used there, and there can be a variety of different insulations used. We don't know the fire performance of those particular insulations. We don't know the compressibility of them. We are relying on our product having been tested to a certain compressibility and obviously a certain fire performance. So it's very, very important that the contractor cuts back the insulant and takes the cavity fire break to the back of the panel. Okay, it cannot sit against the insulation. So the product that we have, these Lamitherm CWFS cavity barriers. They are tested to BS 476 Part 20. They're tested in the static joint test, and we have that 1200 millimeters test, which is okay for the UK market as it stands. But we do have a series of 1364 Part 4 tests that, as I pointed out, are far more realistic of a curtain wall scenario, and we believe that as the E-tag is in place, this is what people should be testing to now. The Siderise, the Lamitherm product, is the only one to be tested actually in a non-fire rated facade. We used an aluminium facade, but we protected the facade. And part of 1364 test is that there should be a 1 metre sort of protected area so that you're reducing this risk of breakout through the windows and break back in to the floors above. We actually achieved 210 minutes integrity and insulation, and that was with a floor slab deflection of 67 millimetres, equivalent to 34% of it, and a facade deflection of 35 millimetres. I won't go too much into certifier approval at this point. We have the product certified approved. Wilf Butcher will be talking this afternoon about third-party certification and the importance of it in the industry. But just to say, it is a certified approved product. And we will be looking to have it fully CE marked. It's not a short process, CE marking your product, but the CE marking will be in place by June of next year. the mullions and transoms that we used in the test were 50 by 105 mil mullions and transoms. You had standard double glazed units in there, standard aluminium systems and spandrels. So it was a pretty standard system, and yet we were able to get over 3 hours out of that particular system. So it just shows that that is achievable. So I'll just finish really saying that as a company, you know, acoustics, fire, thermal, fabrication, we're there to assist you. Please, you know, use us, abuse us. Thank you very much.